Hello, everybody. We are in week 6 of office hours, and also in the midst of the final exam. Actually, we're time-wise, we are not really in the midst of the final exam, but probably if we consider the amount of submissions that have been made, we are closer to that. I don't know. I should have checked where we are with the submissions. Just I've never really paid attention with the midterm since we give the weekend and the the weekend and the Monday, whether there is typically any difference when students end up. No, this did not work. Sorry. Okay, accept. Okay. So the midterm exam is still ongoing. I will check at some point what is the status of the current submissions. So we will not talk about the midterm exam. The official the closing time for the exam is midnight anywhere on Earth tonight. Both of the deadline that's currently configured in Canvas and the deadline that's currently configured in ProctorTrack are showing it as midnight Eastern time, and I will make an adjustment to both of those dates to be midnight anywhere on Earth time zone. I think I posted in one of the questions regarding this that when we open the exams, we keep the Eastern time zone as an end date or closing time, just because otherwise the exam you would have to configure it on the exam doesn't let us specify the anywhere on Earth time zone, and so any other configuration would mean that we would explicitly configure it to tomorrow's date. And the couple of times that we opened an exam with the sort of real time and date of the closing of the exam configured in the system, we had students who said that they kind of mistook the date and they thought that we had the midnight of that date. And so in order to avoid that, we keep it to the original date as late as possible and make the time zone adjustments fairly late prior to the actual closing of the exam. So we will make that adjustment. We have not had any situations where something came up for a student where we had to make some last-minute accommodations, but we reserve the right that something like that might happen. So the fact that the exam window is going to expire at some point over the next 20-hour period or so does not necessarily mean that the exam closes for real, because there may be some situation where we'll have to extend the window to accommodate somebody else. If we get a message from Dean of Students, for instance, that something has happened. So once everybody has finished taking the exam, then we will let you know that you can potentially discuss the exam on Piazza. Once the exam officially closes, I will do the grading of the exam, and we will distribute the grades for the midterm exam prior to the drop date, and we will also distribute the we'll distribute some feedback on the answers, and we will do that at some point after the drop date. So that's as far as the midterm is concerned, and we will discuss it more in one of the upcoming office hours. I guess just to point out, the grades from the midterm, once they get released, those you will you will get your own grade, and then you will get some information about distribution of the student grades across in terms of minimum, maximum, median, mean and median. And so you will have some idea how you did sort of in absolute terms and then relative to the class, and we'll give you some insight into whether the distribution that we see this year, whether it's substantially different from past years or not. And so that can hopefully give you some idea on what to expect from, you know, any changes in the curve distribution that we've seen with past years. One of the things that, well, yeah, so we'll talk more about the grading, et cetera, later. Okay, so in terms of, let me just point out a couple of things. So, okay, so the drop date is 6/29. Yes, you will have the exam before, just I'm not 100% sure. I think we'll only have one more office hours between now and then, and that's going to be next week. And that office hours will be held by Tony, one of our head TAs, and he has been with the class for many semesters, so he'll give you some insights into what we've seen in past semesters with respect to the midterm. So this is an example of me trying to do two things at the same time, and right now I'm trying to just see how we're doing with whether Canvas gives me a easy way to see how many exams have been submitted in terms of the midterm. Not really, but just by scanning through the reds and the blues, I don't think it's really more than a half. So I think that there's still a number of students that are yet to take the midterm at some point during the course of the day. One thing that we did say, if any of you are actually going to be listening to office hours before finishing the exam, is that especially sort of this round of students that are going to be submitting the exam tonight, and I think that overall the number of student increases, it's going to take ProctorTrack longer to kind of pick up the videos, complete the upload of the videos, and actually do the analysis. And so it may take much longer for you to get some sort of feedback from ProctorTrack that your exam has been submitted, and for us to get the analysis to kind of show in ProctorTrack that the exam is completed. So we've seen it go as much as 2 hours. Oh, sorry, as much as a couple of days, actually, not 2 hours, but way more than 2 hours. I was going to say 24 hours. It doesn't, just because you got a quick update when you finish the proctoring, the onboarding exam, that your submission was accepted and your login in ProctorTrack shows that the test is completed. That doesn't mean that you'll experience the same thing with the midterm. It's a longer exam. There's for real something to be analyzed during the proctoring session. And then there are many of you at the same time. So it just takes much longer for that update to happen. Okay, so that's as far as the exam goes. We'll talk more later. So after the exam, the things that will be happening, so let's talk a little bit about what's coming. We will have, one thing is we will officially open Project 3, and I'll talk a little bit about Project 3 to give you some heads up. And then we will also at this point, everybody's moving into the lectures of parts 3 and 4, or actually part 3. Our online schedule really recommends that you may even be, that you should have sort of concurrently with taking the exam, that you should have moved into studying, into reviewing the lessons from part 3 L1. That even during class week, those could have been your new lessons that you are watching as you're reviewing the past material. And the main part for that is to make sure that everything is aligned everything's aligned with project 3. So project 3, for project 3, you will be, project 3 has 2 parts, and the second part of project 3 is really dependent or very related to content that's covered in P3L3 specifically. And so the reason we've sort of recommended this schedule is to make sure that kind of by the time that you're getting ready to move into the second part of part 4, the second part of project 3 is that you would have completed the lesson on shared memory and IPC, the lesson P3L3. And so then some sequential schedule of covering the lessons would have meant that you would have reviewed P3L1 already, and that this week you'll spend on P3L2 and P3L3, so that kind of next week you can move into P3L4. But more importantly, you're done with P3L3 so that you can handle part 2 of project 3. So let me pause for a second and talk a little bit about what's happening in part 3. So far in the material, in the lessons, we had in part 1 a really high-level overview of different components of the operating system, and then we spent in part 2 primarily dealing or primarily talking about threats, what is an execution context. The operating system has some abstraction of what's an execution context, how it allocates resources for these execution contexts, how it manages their resource allocations, and then how it ultimately provides some isolation. But then also with respect to threats is how it, what is the support for threading at the kernel level, at threading libraries, how do we deal with synchronization, concurrency, what are different ways to implement, to structure services with multiple threads, and then some on the different performance trade-offs that you can observe in different multi-threaded or multi-process-based implementations. In part 3, we're going to take a subsystem of the, we'll look at different subsystems of the operating system. So scheduling, memory management, the I/O, and then we'll spend a little bit more detail on each of them. So we have sort of 5 of those lessons, and then the last lesson, it's looking a little bit at virtualization, which is kind of another layer in the system software stack, and also at some of the hardware advances that have happened in order to better support virtualization. So for each of P3L1 to P3L5, you can think of it as we spent some amount of time at high level describing some of the main concepts, main abstractions, main mechanisms related to a particular subsystem of the operating system, scheduling or memory management. And then for different one of these modules, then we end up in kind of different amount of detail discussing maybe some of the newer, more interesting developments that have happened. And this is in part because, perhaps, sort of with some subsystems, there hasn't been maybe that much innovation, at least at the time, in terms of the mainstream operating systems, at least at the time when these lessons were recorded, whereas in others, there's been more kind of mainstream innovation that deserves its place in, deserves its mention in an introduction to operating systems class. For instance, the fact that we have multi-core processors, the fact that we have hyper-threading, sort of these are mainstream features of general purpose platforms. So it does make sense that as part of the basic scheduling lesson that's in an intro to operating systems class, we spend some time to talk about maybe how these hardware properties, presence of multiple cores and presence of hardware multi-threading, how they will sort of influence how we do scheduling, how maybe they'll change what's required to support a different scheduling algorithm or something like that. So that's basically the rationale why in some cases we end up, in some of these lessons, we end up spending a little bit more time with these papers. So if you take a look at the schedule, you will see that with the scheduling lesson, with the synchronization lesson, we supplement them with some additional reading in terms of papers. And then P3L3, which is the lesson on shared memory and IPC, that one we really supplement with the project 3. P3L3 is probably most directly related to the memory management lesson, P3L2, and we do recommend that you kind of cover these in sequence. But other than these two being covered in sequence, I think that it's fairly easy to sort of reorder in some way some of the other lessons. What that means is that once you're done with the midterm exam, you can shift to going through P3L2 and P3L3 in order to be ready, better prepared for the project. And then if you need to, you can come back. If you have to skip through the scheduling class in P3L1, you can come back to it once you are sort of set up with the project assignment, you started working on it. So as far as the research papers go in this part of the lesson, sort of in this part of the semester, you can assume that just like in the previous part of the semester, we provide some research papers. We don't discuss those research papers and in every detail in the lesson. So whatever portion is represented in the lesson, the assumption is that you are responsible for that. And then there's some portions of those research papers that are really not discussed, and you feel free to skip them. I said this already. I find, I think that it would be easier if you go through the lesson and then go and read the paper and see where you need to spend more time. But of course, you can see what works best for you and what's the most effective way for you. Other than the material that's in the research papers, every one of these topics, scheduling and memory management and synchronization, that's very well represented in any operating systems textbook. So you pick any one of your favorites, really any edition. And even if you go back multiple editions, you will find good treatment of some of the concepts that are described in the lessons. 3 Easy Pieces, the online version of it from Andrea and Ramsey Arpachi-Dessous is also a great example of a textbook that has fairly good actually not fairly, but really good representation of these concepts. So my recommendation is to make sure that you reference these other sources as you see fit. One of the things that I've pointed out before, you take any one of these topics, whether it's like this, if you take like files, lesson P3L5. So we talk about sort of IO, right? So we touch on during this lesson on kind of IO subsystem. We touch on storage, we touch on networking, we touch on file system, right? There's so many different components that we spend a little bit of time on in this lesson. And so if you take a look at if you take a look at the textbook, you'll see that material is covered across multiple chapters, right? If you take a look at the P3L2, which is the memory management, you'll be, again, it will be kind of physical memory management. It'll be a separate chapter on virtual memory management. There may be additional multiple chapters serving a large body of work on different flavors of memory allocation algorithms and page replacement algorithms and whatnot. And we cover it in a single lesson. So clearly there is much more work that has happened in the community in general that describes specifically some decisions or implementations that are present in concrete operating systems, commercial or research ones. They're also very useful, but we're spending time on, this is an introduction to operating systems, right? And so our goal is to make sure that you have good understanding on what are some of the what's the functionality that's for within a particular subsystem that the OS is responsible for. What are some of the main ways that it can be realized? Kind of historically, what are some of the things that we've tried and how we've arrived at the current designs, and to give you some idea of what some of these concepts are, and maybe how you can follow up on if you need something specifically to cover in more detail. Unlike so that's the goal of these lectures are really to give you that ability to get the gist of what's represented in more detail across maybe multiple chapters in a textbook. And then if there is some piece that you don't understand, you can more easily navigate and not read 200 pages worth of text, but focus on the subsection or subchapter that you need to really spend more time on. One of the things that's going to happen in the second part of the semester is, unlike in the first part, where really most of the conversation was about threads, in the second part of the semester, we'll really cover many different topics. And so it will, I think in a way, it will feel that there is, there's a lot more going on in the second part of the semester. So giving you fair warning now is just make sure that you follow as much as possible, follow through with the lecture material, and be as well prepared for the the final exam. I know we haven't finished the midterm, so talking about the final is a little bit premature. Just pointing out to the fact that you will have many distinct topics to study for the final, whereas for the midterm, it feels like most of what you need to study has to something to do, kind of threads is the common denominator, whereas here it's much more diverse, and so it can feel a little bit more overwhelming if you were maybe successful in spending 3 days on reviewing the material for the midterm exam, or watching for the first time some of the material for the midterm exam. For the final exam, I think it will feel much more overwhelming, not just because there are more topics, but because the lessons are on different topics. Not just because there are more lessons, but because the lessons are on different topics. That's what I meant to say. Okay, so that's some heads up about what's coming up in the semester with respect to the lectures. I still can't figure out how many students have for real taken the exam already. So other than to sort of approximate that. Okay. So then I will spend the rest of the time, today's office hours, I'll tell you a little bit about what to expect, say, from project 3 going forward. So project 3 will have 2 parts. Part 1 will be really more just general C programming. It will kind of, the project overall will seem like it's following on the project 1 that you completed last week, but you're not required to build on the implementation of project 1 that you completed. Instead, you will have a brand new set of starter files and a brand new set of requirements of what you need to implement and what you need to modify and how you need to modify. In project 1, you implemented a multi-threaded, at the end of project 1, you implemented a multi-threaded web server, and you implemented a multi-threaded client, you implemented a multi-threaded file server, and you implemented a multi-threaded client, and this client knew how to make requests using a protocol called GetFile protocol for files from the multi-threaded server. So that was what you had to do in project 1. In project 3, the project that's coming up, you will need to do the following. In the first part of the assignment, you will need to basically create a proxy, a multi-threaded proxy, and this multi-threaded proxy is kind of something that's going to live between your client and some real web server. Right? So your proxy will accept requests for files from the client, and then will relay those to a server, and will fetch files from that server and bring those back. And the first part of the assignment, you can think of it, it's basically your GetFile server that you implemented. That sort of, it looks like a server from the perspective of the clients, and then it kind of looks like a client from the perspective of the ultimate server from where the files are fetched. Except the way that this implementation, this interaction with the server is going to happen is going to be in a way that that really follows modern implementations of web servers and web services. So the learning in terms of the practical experience here will be more about some aspects of web programming and web service programming, and we'll continue using C, and in terms of the multi-threaded part, you're really just going to have the same structure as what you had in project 1, where you have a multi-threaded client and a multi-threaded server, and there is a worker in the server that is just responsible for relaying a request from the client over to a remote server, waiting for the callback to come back, and passing that on to the client. And a lot of that will already, there'll be multiple pieces here that will be provided to you. So you are not, again, going to be graded for correctly implementing all of the boss worker interactions between the between the threads and the client. That will already be provided. You'll really need to implement some of the proxy logic, which means you pick up a request, pass it to the remote server, you wait for that response to come back. You'll need to make some adjustments to exactly what those request responses look like in order to match more what what HTTP requests look like, but that's about it. So the first part of project 3 will be fairly straightforward, meaning that it's intended to kind of give you a way to reassess where you are with maybe the skills that you've been picking up in Project One. So for those of you that came in the class with good programming skills, you probably just went through Project One. Sort of Project One was hopefully it provided some learning aspects, but there wasn't a challenge of, oh my God, how do I do X in C, right? If you had good programming skills in C. For those of you that didn't, in addition to having to deal with maybe thinking about threads and thinking about synchronization and thinking about how to write kind of server programs, you also have to deal with C, and that probably made many things more overwhelming, right? And at the end, you probably learned a lot, but it's probably harder to disentangle of, did you learn enough, or what was the real challenge? Was it that the assignment was difficult, or was the fact that you had to learn all of the aspects of the programming language and programming environment? That was what was providing the biggest challenge. So then this first part of Project 3 is intended to give you a sense to kind of see where you are with C, right? And it's going to be, from that perspective, it's going to be straightforward, because it's primarily supposed to have you reevaluate those parts of the skills. The reason why this is useful at this particular point of the semester is because at the end of next week, we have the drop date, right? So you will have the grade from Project One, and you will have the grade from the midterm, but there are a lot of points that are still up for grabs at that point, right? There'll be Project 3 that's up, that's not graded, not submitted, Project 4 not submitted, and also the final exams. If you look at the total number of points, you'll need to make a decision of how you feel you're doing in this class by the time of the drop date, based on the scores that you have on these two initial assignments, the midterm and Project One, and there's a lot that's still outstanding. So what we recommend is to make sure that you kind of really think about your experience with the first part of Project 3. If you're really struggling with the first part of Project 3, because you're sort of still feel that you're overwhelmed with just figuring out how to do certain things with C, then we recommend, that then you really need to think about whether you want to stay in the class. The reason is the second part of Project 3 will be a combination of, it will still be C-based, but it will also require new learning. It will basically challenge you, because there'll be new material, new concepts that you will need to learn and that you'll need to program for and around. And if you're still struggling with, just the basic C things, then it may be a bit too much, right? And then there'll be Project 4, where we'll also throw in some of the C++ concept, just to relate things to a little bit more modern technologies. So that's why we recommend that you spend more time. That's why we kind of structure the assignment like this, so that the first part of Project 3 is really giving you this chance to see how are you doing from the practical component of the course, and make a better decision what to do next. The second part of the project will, as I said, it will be related to one of the lessons. It will be related directly to lesson P3L3. And this is the lesson that talks about interprocess communication, about shared memory and interprocess communication. And what you will need to do in this assignment, you will need to implement the interactions between that proxy that you created in the first part of the assignment and a caching service, and in such a way that the proxy and the caching service are interacting via shared memory. So kind of to break things down for you again, so we had the clients that you got the multi-threaded client that you guys implemented in part one, in project one, and you had the multi-threaded server. So those you implemented in project one. So now in part one, you're essentially putting between them a proxy, right? And then, but this proxy is just doing the relaying of requests between the client and some remote server, and doing nothing else. And then in part two, you will add a proxy process, sorry, a cache process that's sitting on the same machine, on the same physical machine as the proxy. So every request from the client, when it comes to the proxy, instead of being forwarded to the server, it will go to this cache process. And if the request can be served from the cache, then that file will be fetched from the cache and returned to the client. In general, if there is a miss in the cache, then the proxy would go ahead and forward the request to the server. You will not be implementing this. And then also in general, the way you would basically just to relate this to some real world systems, it actually makes perfect sense to have kind of one entity be this entity that's responsible for the proxying functionality, right, which simply deals with maybe relaying requests, thinking about load balancing, thinking about how certain requests need to be redirected, and then a completely different entity that deals with the actual implementation of the cache and different, cache replacement policies and cache partitioning policies and whatnot. So that's a perfectly reasonable design. And then also a perfectly reasonable design is that, sometimes you may want to have these two services run on two physical machines, and then they would be talking via sockets or some protocol like that. And then sometimes they can be co-located on a single physical machine. Why? Because we have machines that have enough cores and enough memory and enough storage so that they can host multiple services, right? And then when these are running on the same physical machine, then there really isn't a need for them to be communicating using the full protocol stack, sending packets to the network and then getting them back the same way that they would be communicating when the two servers are running on separate physical machines. Now, in this assignment, you will actually explicitly program the communication, the interactions between your proxy and your cache, and the threads in the proxy and the threads in the cache, in a way that does not use sockets for moving files from the cache into the proxy, but instead relies on moving data via shared memory pages, and on coordinating the data transfers using some form of inter-process communication that can come in the form of message queues or semaphores. So that's what you'll have to do. And we'll post the assignment. I will provide more information on it, and then we'll also next week you'll get a little bit more insights on and advice for project 3. So for part 2 of the assignment, you will have to program these two to explicitly use this alternative type of interactions and alternative type of communication. In practice, what we'd expect from the system software stack whether it's just the operating system or higher level libraries, or also, some of the virtualization layers, like hypervisor, etc., is that they would be fairly intelligent, and that they would be able to figure out that, gee, I need to send the message to a process, and that process is sitting on the same physical machine. So I'm not going to take this message and send it out to the network and wait for it to come back. So we'll have some mechanisms at different levels, both of the kind of on the OS side and also on the network hardware side, to figure out that we don't really need to do this. And what those are differs from systems to systems and from system software components, across system software components. But by implementing this functionality explicitly yourself, is you will sort of be able to understand what are some of the ways that processes can directly communicate in a single when they're running on the same machine. B, you will really be able to understand how memory management works and how protection around memory management works, because you'll get to learn how do you use shared memory, how do you make sure that a page of memory is shared among two processes. What do you need to do in order to do that? Which data should or shouldn't find its way there? How do you make sure that data finds its way there? So this is kind of going to teach you a little bit about both how memory management works, how protection works around in terms of memory. So that's one goal of the assignment. And then the other goal of the assignment is to kind of, in addition to just using shared memory, to expose you to some other forms of inter-process communication that are used, that are typically supported by operating systems. So you'll have some flexibility there on choosing what exactly you will get to use, and so but that will give you some idea. That will give you some understanding in terms of what are some of the other OS level mechanisms. So so that gives you kind of both some overview of what's Project 3 going to be about, how is it related to the first project, how is it related to maybe the kind of server architectures that you would see in real world, and then gives you some insight into what are some of the learning outcomes and what's our hope that you will get out of both part 1 of Project 3 and also the second part of Project 3 in terms of which pieces of the OS behaviors which are you expected to get most insight on. So that would be, that's sort of the overview of what you can expect from Project 3. In terms of some additional advice, just take a look at whether there's anything interesting that's going on. In terms of some additional advice on Project 3, I think it'll be much more useful if you we discuss that after you've had a chance to get going with the assignment. So I'll defer that to, I'll leave that for some of the upcoming office hours. For now, I will sort of point out that unlike Project 1, for Project 3, we, for the second part of Project 3, we actually see, we offer our students the flexibility to have much more design freedom. So there'll be multiple choices in terms of APIs, in terms of kind of how you want to structure, how you can structure the interactions between the threads in the proxy and threads in the in the server, etc. So depending on and threads in the cache, and depending on all of these things, there are different ways how you can design the protocol, how the two types of threads, the proxy threads and the cache threads, how they're going to pass information regarding the requests that need to be served, pass information regarding which particular shared memory segment is going to be used to move file from one process to another, to how are they going to synchronize, etc. So all of those are going to be some design dimensions that you will have the right to choose. And so I think that makes the project fun. I think that some of these concepts are not things that many even skilled programmers end up using in a day-to-day basis. As I said, there is the takeaways really on kind of learning more about the memory management and IPC mechanisms in the OS kernel. But we've seen that there's less of kind of that broader popularity, broader experience among the students in the class with some of these APIs. So in that way, it ends up evening out some of the advantages that that we saw maybe in the first part of the semester, where maybe there were some students that already have programmed with threads and others not. When it comes to programming with shared memory, we see less of students that have had prior experience, and so that makes it more of similar playing field for all the students. And then I think that in terms of I think that the other aspect is that most of the challenging part of the second part of the assignment, I really think that the first part of the assignment is fairly straightforward. But the challenging part of the second part of the assignment is really in how you're going to design how your proxy and your cache threads are going to interact amongst each other. And doing that, we've had a few years ago, we had a case when a student reported that he spent like a week working through pencil and paper, just the design, kind of all the different cases. And once he had that done, it was a matter of just a day to get everything implemented and coded. So I think that the design part is where the bigger part of the challenge is. And I think that that's kind of another reason why A, students enjoy it, and B, even students that, the students don't feel disadvantaged. So we've seen a lot of students who came into the class and maybe even struggled quite a bit through Project One because of maybe some gaps in the programming skills. We see a lot of them we see that they're just as able to do well in Project 3. So kind of that part of the advantage evens out. So that's as far as Project 3 goes for now. Again, we'll post it. We'll give you some helpful hints, and then the next 3 Mondays, I'm traveling every one of the next 3 Mondays. So and actually the next 3 weeks, really. But the way we will do it, we will deal with office hours now is we'll have Tony Masons. He will hold office hours for the class next week. And then I will do office hours the week before, and likely I'll push those on a weekend. I'll give you some heads up, but I will have those. This would be the weekend before 4th of July. And then hopefully everything will go well, and Tony and I will have office hours together, and we'll maybe push those to, I guess Wednesday of the week after 4th of July, so that we are both in town at the same time. Well, but we're both in the same town at the same time. Last time we tried to have office hours together, we didn't make it because I was on a sort of a series of 24-hour, or I don't know how many delayed flights and canceled flights. So I never made it to where, or I made it to where I was headed much later. Still got to spend time with Tony, but by then Tony did hold the office hours. So hopefully, not to jinx anybody, but hopefully that's not going to be the case. And we'll end up doing that together. But so next week, Tony will post an announcement that you will have office hours in the regular part of the week, and then we'll do I'll do an office round of office hours at some point end of that week, by the end of the weekend, because that Monday, Tuesday are really going to I will not have reliable internet service to be able to do office hours. So and then you'll have again a bigger break, but that's going to be through the process of finishing up project 3, and hopefully by then between Tony and I will cover most of the advice that we need to give you guys so that you're well prepared for that. And then we'll be ready to talk about project 4. We'll give you a little bit of heads up on project 4 over the next office hours, or once we've made sure that we've confirmed all aspects of it, just so that it's not a full surprise. But we've been planning for some updates to that assignment, in particular because of mainstream Linux kernel phasing out some of the capabilities that were the main takeaways from the existing form of project 4, but more to that, more on that over the next couple of office hours. So let's see. I think that all from me. So you will hear from us regarding official closing of the exam. I will update the exam window to reflect the Anywhere on Earth time zone. You will get a confirmation from us when the exam officially closes. You will get grades from project 1 and midterm before the drop date. You will get project 3 posted, and you will see Tony next week and me the weekend, by the end of that weekend, 29th, 30th. And for project 3, you will need to cover really P3, L3. We recommend covering P3, L2 before P3, L3. But if you've missed the scheduling class on P3, L1, you can kind of delay that and come back to that one after you've started working with the assignment. Actually, to start the project project 3, you don't even need you don't need any of the parts of any of the lectures from part 3. So you can really just start it based on what you've learned so far in terms of just threading, client-server interactions, and C. So you can. Part 1 does not depend on anything. It is part 2 that depends on P3, L3. So, okay. So I will see you at this point in, I don't know, something like 13, 14 days. Not this coming weekend, but the following weekend. And Tony will do office hours at some point next week. Okay. Bye-bye, and good luck on the midterm, those of you that are yet to complete it. Okay, bye.